October 12th, 2020 mini lesson. Number 1. Brett has 18 cans of regular soda and 12 cans of diet soda. He wants to create some identical refreshment tables that will operate during the football game. He also doesn't want to have any sodas left over. What is the greatest number of refreshment tables that Brett can stock? So that keyword, greatest, and none left over, and some identical, those are all going to be keywords to when we find greatest. We need to find the greatest common factor. So we need to have 18 regular sodas, I'll put that in pink, and 12 cans of diet sodas. All right, let's do that. Let's do that in blue. So we're going to find our greatest common factor of 18 and 12. All right, so let's have 18, 18, and then 12. Let's see. All right, now, I go up a little bit. There we go. All right, so when we factor these, 18, what times what equals 18? I know 9 times 2 equals 18. I know 6 times 3 equals 18. We cannot do 1 times 18 because then, remember, we'll go on and on and on, and we don't want that to happen. So other than 1 in itself, let's do 6 times 3. Let's do that. Let's do 6 times 3. Is 6 a prime number? No, because we can break it down. It's called a composite number. We can break it down even more. Is 3 a prime number? Yeah, so we're going to circle it because the only 2 factors of 3 are 1 in itself. But 6, what times what equals 6? Oh, 2 times 3 equals 6. Yeah, 2 times 3 equals 6. Is 2 a prime number? Yes, it is, because the only 2 factors are 1 in itself. What about 3? Is 3 a prime number? Yes, it is, because the only 2 factors are 1 in itself. Are there any more branches to continue and break down? Nope. So our prime factorization of 18 is going to be in order from least to greatest. We're going to have a 2, a 3, and another 3. And remember, the prime factorization is when we multiply them. I like to make sure we have those numbers down first. We are multiplying them because then the prime factorization means that you can multiply these 2 times 3 times 3, and you will get 18. For example, 2 times 3 is 6, and then when you multiply that by 3, you get 18. Notice and remember, we only write down our circled numbers because those are the prime numbers. We're writing down the prime factorization. All right, let's do 12. What times what equals 12? I know 6 times 2 equals 12. Ooh, I also know 4 times 3 equals 12. Let's do 6 times 2. That was the first thing that came to my head. 6 times 2. Is 6 a prime number? Nope. So we're going to be able to break that down. What about 2 though? Yeah, 2 is a prime number. Why? Because 2, the only 2 factors are 1 in itself. That means we can't break it down anymore other than 1 and 2. But 6 we can. So 6, just like we did over here. 2 times 3. 2 times 3 equals 6. Is 2 a prime number? Yes, it is. We just said it. The only 2 factors are 1 in itself. Same thing with 3. It's a prime number because the only 2 factors are 1 in itself. Now, in order from least to greatest, the circled numbers, we have a 2, we have another 2, and we have a 3. Remember, we're multiplying these. All right, let's match the socks. Okay, so I'm going to use some highlighting. Do they match a 2? Yeah, they do. So I'm going to put that in yellow. What about, do they share 3? Yeah, they do. Not another 2, but they do share 3. I'll put that one in pink. They do share 3. Anything else that they share? Another 3? Nope. Another 2? Nope. So we're going to remember, take 1 from each pair. So we have a 2 and a 3. Now, multiply these shared factors. So 2 times 3. I know that that equals 6. So our greatest common factor, or the GCF, is 6. That's it. Great job.